Video, I will determine whether a sequence is convergent or divergent. I will do 4 examples in this video and then another 4 examples in the next video. So the first one, we have the nth term, right? So what is the nth term by the way? So let's say you have a sequence, right? So let's draw a sequence. Just draw a sample sequence. So sequence. So what do you have? So let's say we have a A1 and then A2, A3, A4, A5 is a list of number, right? So and then we go all the way to the end. All right. So what we are trying to do is this one right here. Is this as n approaches to infinity? Is an approaches to infinity, or an approaches to a real number? Approaches to a number. So if you get infinity, then that will be a diverge. That equals to a real number, then that will be a converge. All right. So the first one, so number one, we have an equals to 3 plus 5n squared divided by n plus n squared. So we have to take the limit. So we have limit as n approaches to infinity, 3 plus 5n squared divided by n plus n squared. Square, not 3. So this one, please write the limit out. All right. Write limit use equal. So how do you still remember how to solve this type of limit? Do you still remember the stuff you learned in your differential calculus class? So to solve this type of limit, first, listen, you have to find the highest degree, the highest exponent in the denominator. All right, determine the highest exponent in the denominator. In this case, is a square. So therefore, on top and bottom, you have to divide each term by n squared. All right, so that is equals to limit as n approaches to infinity. We have 3 divided by n squared plus 5n squared divided by n squared. The denominator, n divided by n squared plus n squared divided by n squared. Do we care about the exponent in the numerator? The answer is no. Why? Because in the numerator, we can afford having a 0 or infinity. In the numerator, 0 is fine. Infinity is fine. But in the denominator, I do not allow a 0. Because if you use a third degree, then you will get a 0 in the denominator. So let's take a look at this one real quick. So limit as n approaches to infinity, you have 3 divided by n squared, right? Plus 5. And then the denominator, you have 1 divided by n plus 1. So the reason I do the red thing is because I want to end up with this one. That is what I want. What if you use a third power? Think about this. Look at the red fraction. What if you use a third power? Then the 1 in circle will not be 1 anymore. Then that will be 1 divided by n. As n goes to infinity, then you have a 0 plus 0 in the denominator. That is bad. I don't want that to happen. That's why when you divide each term by n raised to a certain power, that power must be the biggest power in the denominator. All right, that is a skill you learn in differential calculus when you were learning how to evaluate limit. So this one, as n approaches to infinity, one concept that you have to recall from your differential calculus is a number divided by infinity is equals to 0. Just take any number, let's say 5, divided by infinity. So divided by a number like this, so you will get a quotient that is very close to 0. All right. So we have what? What do we have? So we have a 0 plus 5 and then a 0 plus 1 that is equals to 5. 5 is a real number, so that means the sequence converges. So you just write converge. What if that equals to infinity? Then that will be a diverge. Okay, number 2. Switch color for each problem. So number 2, we have an equals to n to the 4th divided by n to the 3rd minus 2n. Same thing, we take the limit. So limit as n approaches to infinity, we have n to the 4th divided by n to the 3rd minus 2n. So since the highest degree is 3, then I will have to divide each term by n to the 3rd. Let me do this in a different color. So 1 divided by n to the 3rd, 1 divided by n to the 3rd, and then we go back to the orange. So n approaches to infinity, we have 4n to the 4th divided by n to the 3rd, that is n. And then the denominator, n to the 3rd divided by n to the 3rd, right? Minus 2n divided by n to the 3rd. So what do we have? So that is n, and then this is 1 divided by 2 over n squared. I don't care those fractions because the fraction will just go to 0, right? But this time we do have an infinity in the numerator. That's why I picked this problem. And then in the denominator, I have 1 minus 0. So what is infinity divided by 1? Infinity divided by 1 is equals to infinity. So since the limit approaches to infinity, then the sequence is divergent. That's how you do it. Simple, right? And let's take a look at number 3. So in number 3, we don't have a fraction anymore. So number 3, we have a an equals to 3 to the n times 7 raised to negative n. So which is 3 to the n negative exponent, right? 7 to the n. So that is the same as 3 divided by 7 to the n. I didn't use any calculus in here. I just used my algebra, because in algebra, that's how the exponent works. They both have the same exponent. So I can do 3 divided by 7 first and then raise the whole thing to the nth power. If you don't remember this law of exponent, you have to review it. This is not even from pre-calculus. This is from elementary algebra. And then you take the limit. So limit as n approaches to infinity, you have 3 divided by 7 to the n. There is no algebra skills in here. 3 over 7, that is between 0 and 1, right? So that is between 0 and 1. So to be specific, you can use your calculator to divide them really quick. So 3 divided by 7 is around 0.43. So 0.43, if you raise that to a huge power, the product is very close to 0. All right, so this one, when you raise that to a very large power, that is just equals to 0. So since 0 is a real number, then the sequence is convergent. Now, you might want to ask me, hey, what if? I know people ask what if. So what if I have this? I have limit as n approaches to 0. I have 7 over 3 raised to the n. That changes the whole game. 7 over 3 is greater than 1, right? So 7 over 3 is around 2.33, is around 2.33. So if you raise 2.33 to a very big power, this is going to give you a very large quantity. So this one will be equals to infinity. As a result, that will be a diverge. You can write div for divergent. All right, if you do a 7 over 3, that changes the whole game. Okay, next one. What if you have a square root? Okay, number 4. You have a an equals to the top you have 3 times root n, the bottom you have root n plus 2. What if you have a square root of n? So this one, you have to look at the highest degree in the denominator, which is a 1/2, right? Because the square root of n is n raised to a 1/2. You still remember your algebra. So square root of n plus 2. So that means we have to divide the top and bottom just by that term. So that equals to limit as n approaches to infinity. We have 3 root n divided by root n. That will be the top. The bottom will be root n divided by root n plus 2 divided by root n. So what do you have? So we have limit as n approaches to infinity. The top we have a 3, the bottom we have a 1 plus 2 divided by root n. I don't care about the fraction at all, because as n approaches to infinity, the fraction becomes a 0. So that is a 3 divided by 1 plus 0. That is equals to 3. 3 is a real number, so that means the series is convergent. Let me remind you this one more time. If you take any number, so let's say a 10, and then you divide it by infinity, 10 divided by a very large value, the result is not equal to 0. Because 10 is not equal to 0, the result is approximately 0, or you can draw an arrow, approaches to 0. Alright, so that will be the first problem, and that is also the end of this video. In the next video, I will introduce 4 more problems of how you do the limit and then determine the convergence and divergence of a sequence. Alright, if you think my instruction is helpful, the way I explain things is helpful to you and to most people, please let me know in the comment section below. As always, like, subscribe, and share my video. Thank you really, really much. I see you all in the next lesson. Signing out.